Hey, this is your help video for 2.6 functions and function notation, f of x notation. Let's jump in. So let's first talk about what is a function. A function is a machine. This calculator's a machine, cell phone's a machine, lots of things are machines. And what makes this machine work is that when I push a button, I know what's going to happen. If I push, let's just turn this on for a minute here. If I push the 1 button, a 1 shows up. That means my calculator is working. That means it's functioning. Now, what happens if when I push the 1 button, sometimes a 7 shows up, right? See, when I push my 1 button, it shows a 1 every time. But what if that were not true? What if when I push the 1 button, sometimes a 2 showed up, or sometimes a 6 showed up, or sometimes it put a plus sign? I think you and I would both say that the calculator is broken if that were true. We would say it is not functioning. So what's wrong with it? What's wrong with it is the buttons. When you push a button, it doesn't go straight to one answer. It goes to 2 or 3 or 4 different answers, and that would be a problem. Now, if your calculator, if every time you pushed 1, a 2 showed up, and every time you pushed 2, a 1 showed up, that calculator would work. You may not like that calculator, but it would work. Let's think about a vending machine. Vending machines, they have buttons, and you can push the buttons, and you push the button you want, and a product comes out, right? Fine. What if the people who own the vending machines go and move the products around in the machine, and they say, we're going to put the Doritos down here, we're going to put the chips, the cookies up here. They move things around, and so now instead of pushing your favorite button, B2, to get your Doritos, you now have to push C6 to get the Doritos. You wouldn't say that's a broken vending machine. You'd say the vending machine's fine. I just have to push a different button to get what I want. But you know what you're going to get. When you push the button, you get the right product. So what would make a broken vending machine is if you push the button and a different product than you thought came out. You push the button and some other product comes out. Or when you push the button to come out, you'll say, well, I like that. Okay, well, maybe. But what if you own the vending machine? If you own the vending machine, you certainly don't want 2 products coming out when people push 1 button. You want 1-to-1. So let's think about what is a function. A function is something where every input, that's every button, where every button has one and only one output. So when you push a button, one thing happens. One thing happens. That's what makes a machine function. Let's go on to the next one. Which ones of these are good vending machines? Well, let's take the first one. If I push -3, I get a -2. Okay, fine. I know what I was going to get. If I push button 1, I get a 2. Let's call that Doritos. If I push button 1, I get Doritos. But if I push button 1, sometimes I get a Diet Coke, right? Sometimes I get Doritos. Sometimes I get a Diet Coke. So in my opinion, mathematically, this is a broken vending machine. This is not a function because button 1 is broken. Button 1 gives you 2 different answers. It doesn't give you a consistent answer. Let's look at number 2. Now, some people think this one's broken too. They look at this one and they say, oh, look right here. You just told me that if the number repeats, it's broken. But be careful. This is in the outputs. This is in the Y section. So think about a Chromebook or a keyboard. Here, I got a keyboard right here. Think about a keyboard. Are there 2 buttons on this keyboard that do the same thing? Yes. In fact, there are several cases. So how about the shift button? I have 2 shift buttons that do the exact same thing, right? So that's fine. So here I have number 2 could be my left shift button, and number 4 could be my right shift button. And it doesn't matter if I push the left shift or the right shift, I still get shift. This is my output. This is what happens. I still get shift on either one. Now, this keyboard even has more cases of that. I have a number 1. Oh, let's see where you can see it. I have number 1 over here, but I also have a number 1 up here. So I have 2 places I can push with number 1. I have 2 places I can push plus. I have 2 places I can push divide. I have 2 places I can push enter. So it doesn't matter if you have 2 different buttons that do the same thing. In fact, take a vending machine. Have you ever seen a vending machine that has the same product on more than one shelf or row? I'm sure you have. Think about like bottled water. I've seen vending machines where every single slot is bottled water. So that would mean, if that were the case, all of these numbers on the right would be the same because they would all be bottled water. And it didn't, and all the left buttons would be different because you'd still have that keypad. You'd still be able to select whichever bottled water you want. It just wouldn't matter because they'd all be the same. But you wouldn't call the company and say, hey, your bottled water vending machine's broken because every slot has bottled water. It's not broken. It just is boring. It just doesn't have very many options. So we would say that this one is a working vending machine, even though two of the slots give you the same answer, just like a keyboard. How about this one? Every button's different. This one's fine. How about this one? I see a broken button right here. Button 3 is broken. Gives you two different answers. So we have two good vending machines and two bad vending machines. Two functions and two things that are not functions. Let's go on to the next one. Same idea. So on this one, two of them are good. One of them's not good. Let's do this one with you. I'll have some more to practice later. So which one is the bad one? Well, I think this one's the bad one because the 9 button repeats. The 9 button does two different things. So this is the bad one. This one, everything's different. It's fine. And this one is also fine, even though the outputs repeat. That doesn't change it. The outputs can repeat. Remember, that's like having two shift keys on your keyboard. Nothing wrong with that. All right, let's talk about another idea. In math, if you picture this in a vending machine, you'll be fine, but it kind of looks different in a math class. But this is our map of what all the keys do. Here we go. This is our map of what all the keys do. And then what we're saying here is F is your vending machine. F is your function. It's your vending machine. It's your machine. So this says evaluate, or like, what does your machine do when X turns into 6, right? When X turns into 6, that's like saying that you push button number 6. When you push button number 6, what comes out? Well, that's pretty easy. You push button number 6, what comes out? I think you get 60. And then this says the opposite. This says, what about your function? What about your machine if it gives you a number 5? What is your X? So the X is your buttons. So this says, what button did you have to push to get a number 5? So to get a number 5, you would have to push the 8 button. To get a number 5, you'd have to push the 8 button. So let's kind of say that one more time. So the first one traded the X for 6. That means you know the X. The X is 6 because it traded the X in the f of X for 6. You know that you're pushing the 6 button. And it says what comes out. This one, you don't know the X. It says X equals blank. You don't know the X. So what you do know is the f of X. It says here f of X is 5. So follow along the f of X row until you get to 5 and say what X goes with that button number 8. Cool. Let's try one more practice here. Evaluate F at 2. Evaluate your function at button number 2. Well, you can see right there it's 48. Right there. Cool. Let's cruise along. So this one, number 6, the domain and range. And we've talked about domain and range a little bit on a previous assignment. In this case, the domain means a list of the buttons on your vending machine. So the boss says, somebody calls the vending machine company and says, hey, you got a broken vending machine. And they said to you, hey, go down and check out that vending machine. And you're like, I don't know how to fix vending machines. Like, okay, well, go down there and make me a list of what's going on with that vending machine. Give me a list of all the buttons. Okay, I got this. There's a button 2, there's a button 4, there's a button 12, a button -15. Oh, I got a period in there. Let's get that out of there. It's supposed to be a negative. There we go. Got a type right. And then a -7. So I made a list of the buttons. And then the boss says, yeah, great. Also make me a list of the products in the vending machine. So I got Doritos. I've got Diet Coke. I've got Grandma's cookies. I've got whatever, right? I'm making a list of the products in the vending machine. And then the boss says, okay, now check it out. Is it working? Is this machine doing what you think it's supposed to do. And you look at it like, yep, that one's working fine. Every button gives you one and only one answer. So we're good. That's a good machine. All right, which ones are machines? I think you can do that. Same thing, we just did this one. We've done these. Okay, this one is a little trickier, so I'm going to slow down on this one. This one says evaluate your function at 5. That means button 5. So at button 5, you get a 39. This one says, when do you get a 70 out of the machine? What button do you have to push to get a 70? And you say, I got this. It's number 1. Oh, I didn't get it perfect. I should probably quit math. No, don't do that. So look back. What happened here? You're right. But button 1 does give you 70. But if you slow down, you notice that you've got 2 buttons that give you 70. So you say, well, how do I put 2 buttons? I just put a comma, right? Buttons 1 and 4. Buttons 1, comma 4. 2 buttons give you 70. And now you've got all the points. All right, that's just more review. And oh, good. Let's talk about graphs. So when a function is represented by a graph, it works the same way. It just looks a little different. So let's say that you push button number 1 right here. You push button number 1. How many answers do you get? So you kind of look up, you look down. At button number 1, I got a 0. At button number 2, I got a 1. At button number 3, I got 2. At button number 4, I got 3. So anywhere I push the button, I only got one answer, right? So I push button number -2, and I go down and find the line. Bink, I got the line. So this one is a function. This will make more sense as we go along. How about this one? This is also a function. I think this one might make more sense to think of in terms of money with graphs. So this is your money over time. So would it make sense to say that your money increased over time? Like you're working at your job and so you're getting more money over time. Sure. How about this one? You get paid, you spend your money. You get paid, you spend your money. You get paid, you spend your money. That seems very reasonable. How about this one? You get paid a lot, you spend a lot, you get paid a lot. Yeah, that's fine. How about this one though? Oh, look out for this one. How about here at 0, what happens? You have this amount of money, you have this amount of money, and you have this amount of money all at the same moment. That doesn't make sense. You can't have 3 different amounts of money all at the same moment. You have one amount of money. So this is one of those cases where if you push button 0, I get 3 answers. And the easy way to think about graphs is if you draw this vertical line. I'm already trying to hint at this. If you draw a vertical line down, if it touches your blue curve in more than one place on your vertical line, and here it touches 3 times, then it's not a function, not a function. How about this one? If I draw a vertical line down, does it touch at more than one place? Yeah, sure does. Not a function. So you can think of it as doubling back on itself. When it kind of curves over and loops over itself, it's not a function because that's giving you 2 answers at the same time. And how about this one? This one's fine. This one says you always have the same amount of money. Or this is that water bottle vending machine that always has the same product in it all the time. No matter what button you push, it has the same thing. Cool. And the next one's just a review of that. Look for the ones that double over on themselves, and those are not functions. All right.